All right, this video is all about the modern periodic table. Um, just like musical notes, like if you're into music, musical notes are usually separated by an octave. Those notes are usually related, but they're not identical notes. And that's a good analogy for us to use when we're talking about elements in the periodic table, because elements in the same column, which is the up and down, they're related because their properties repeat at regular intervals, but they're not identical. So they share properties just like notes in an octave do, but they're not identical. Mendeleev was the guy who developed his periodic table before the discovery of the protons. He did not know that every proton of an atom has a set number of protons, nor that different elements had different numbers of protons. What he did was actually he arranged them by increasing atomic mass, and he aligned them based on their properties. And then after the proton was discovered, now we actually rearrange them by increasing atomic number. Each row, which is the horizontal, which is the left to right, each row in the periodic table is a period. We call them periods. So period 1, that first row, has two elements. It has hydrogen and helium. And that's because that row, that first energy level, can only hold 2 electrons. Periods 2 and 3 have 8 electrons. So energy levels 2 and 3 can have 8 elements or 8 electrons. Periods 4 and 5 have 18, and periods 6 and 7 have 32. And the reason why periods 6 and 7 have 32 is because the very bottom 2 rows actually fit into periods 6 and 7. You can also find this pattern when talking about energy levels. So the first energy level has 2, energy levels 2 and 3 have 8, and so on and so forth. Each column, which is the up and down, is called a group. Elements within a group have similar properties. Properties of elements repeat in a very predictable way when the atomic numbers are arranged into elements. So this is why the periodic table is so cool, because each row, each element in that row has very distinct properties. The elements in a group have similar electron configurations, which means that their electrons are arranged in a very similar way, and that's the reason why they have similar chemical properties. Hydrogen does not really fit this does not really match the properties of any other group, so it really stands alone. So hydrogen really is kind of its own family. It's placed above group 1 because it has one outer electron, but hydrogen is a very reactive, colorless, odorless gas, and it has about all the substances, 90% of all substances contain the element hydrogen. So it's a pretty big deal. So let's talk about the different groups. You don't need to write all of these down other than maybe the reactivity and how many electrons they have. Excuse me. But we're going to go through these in order. Group 1, these are the alkali metals. So this is the first column. This is the far left column on the periodic table. These are called the alkali metals, and these metals are extremely reactive, and they're never found in nature in pure form. They're always found in compounds. And they have one outer electrons. They have one valence electron. Then the next column over, group 2, these are your alkali earth metals. They're still pretty reactive, but they're slightly less than the alkali metals. They're usually silver colored and they're more dense, and they have 2 valence electrons. Now groups 3 through 12 are what we call the transition metals. They kind of form a bridge between group 3 and group 13. So there's 10, columns in the transition metals, and they have a moderate range of reactivity and a wide range in properties. The lanthanides and actinides, these are the very, very bottom. These are also transition metals, but they were taken out and placed at the bottom, so the table wouldn't be quite so wide. The elements in each of these 2 periods share many properties. The actinides, which are the very, very, very bottom row, those are all radioactive and are therefore extremely unstable. Elements 95 through 103 do not exist in nature. They have actually been made in the lab, and that is true for almost all the elements above 103 as well. Now skipping back over to group 13, this is the boron group because boron is the top element in that column. This contains 1 metalloid and 4 metals. These are pretty reactive. Aluminum is also in this group. It is also the most abundant metal in the Earth's crust, and these have 3 valence electrons. And then we move over to carbon group. These contain 4 valence electrons. Group 15 is the nitrogen group. These contain a wide variety. So they contain 2 nonmetals, 2 metalloids, and 1 metal. They have 5 valence electrons. Group 16 is the oxygen group. This contains 3 nonmetals, 1 metalloid, and 1 metal, and they have 6 valence electrons. Group 17 is the halogens. These are all nonmetals, and they are very, very reactive. They're the most reactive nonmetallic group. They have 7 valence electrons. Now, the group 18 is the group on the far right-hand side of the periodic table. These are the noble gases, and these are very unreactive. They're unreactive because they have 8 valence electrons in their outermost energy level, and therefore we say that the outer energy level is completely full. So here's the look at the periodic table, and you can see where each of the different groups is. So you can see the alkali metals all the way on the left, all the way through the noble gases all the way on the right, and you can see how the transition metals kind of form a bridge in between those two groups. Now, elements are going to be classified as metals, nonmetals, or metalloids. Metals are elements that are good conductors of both electric current and heat. The majority of the periodic table are metals, and except for mercury, they're all solids at room temperature. Most are what we call malleable and ductile, which means they can be kind of hammered out and shaped, and they can also be drawn into thin wires, which makes them really, really good for electric current. Some metals react easily, some don't. Metals react. When they do react, they react by losing electrons. And remember that when we lose electrons, we become positive. So most metals will become cations. So here you can see the difference between the metals in blue, the metalloids in green, and the nonmetals in yellow. The transition metals, those are the ones that are in the bridge. They're elements that are they form a bridge between the left and the right sides. They were actually some of the first elements discovered, and when they form compounds with distinctive colors. Now, nonmetals are very poor conductors of heat and electricity. They have very low boiling points, and most of them are gases at room temperature, with the exception of bromine. Bromine is actually a liquid at room temperature. And they vary greatly in their chemical and physical properties. Now, metalloids are those ones that are in between, so that's kind of like the staircase that you saw. Metalloids are elements with properties that fall between those of metals and nonmetals. So across a period from left to right, the elements become less metallic and more non-metallic in their properties. The most reactive metals are on the left side of the table, and the most reactive nonmetals are on the right side of the table. So here you can kind of see a breakdown where the group 1, those alkali metals, are the most reactive, and then they get less reactive as they go from left to right until you get to group 17, which are also very reactive, and these are the most reactive nonmetals. Thank you for listening.